recording the session, and there's my digital whiteboard. Whatever I write on here, you should be able to see. Can you see that?
Yeah.
All right. So that's the way it works. I've got a bunch of ACT test questions here from a source that is not the same as you have. So
Okay.
these should all be relatively new, and we'll just do the same thing that we did last Monday, which is to just go through these one by one.
Okay.
So if 2x plus 5 equals 17, how do you solve for x?
You bring over the 5, so you subtract 5 from 17.
Okay.
And then you divide 12 by 2.
Okay. Consider the three statements below to be true. Can you read this okay? Because I can blow it up a little bit bigger.
Yeah, I can read it fine.
Okay. All horses that run fast, I'll let you read it. You don't need to read it out loud.
Okay. Um, oh. Is it G?
Horse B is brown. Well, we know horse B runs fast, and we know that all horses that run fast are brown. Yes, good. This is a logic problem. Let's just go through logic a little bit.
Okay.
Usually, you should get this in geometry. Does this look familiar at all? If P,
No.
then Q. Okay, if I say if P, then Q, it definitely does not mean if Q, then P. But what it does mean is if not Q, then not P. Let me give you an example. If you live in Colorado, then you live in the United States. Obviously, if you live in the United States, you don't necessarily live in Colorado, right? You could live in New York or Florida.
Yeah.
So it's clear that if Q, then P is not true. But if I say you don't live in the United States, then it's true that you don't live in Colorado. So this is true only. Okay?
Okay.
All right. Let's go on from that. How much greater than x minus 2 is x plus 5?
I don't remember how to do this.
Well, if I say to you, how much greater than 3 is 7?
4.
Okay, and what did you do? You subtracted 7 minus 3.
Yeah.
So let's subtract x plus 5 minus x minus 2. Get rid of all the parentheses. What do we have?
X plus 5 minus x plus 2.
Simplify.
Mm-hmm. Would it be 7?
Uh-huh. It would be. In other words, is all we need to do is subtract this minus that.
Okay.
Okay. Again, this is a problem that looks like it might be hard only because it's 5 sentences long and it's got some complicated looking equations in it. Don't let that fool you.
Could you just plug port 15 in for B?
Exactly. That's exactly correct. And you should probably have your calculator next to you along with some scratch paper and a pencil.
Okay.
If you don't have it, why don't you go get it? Because we want you to be in exactly the same state you're going to be when you take the ACT test.
Okay, let me go grab my calculator really fast.
All right.
Okay, I'm back.
Okay. So plug 15 in for B. What do you get? You have a TI-84, Lauren?
Yeah.
Okay.
Would it be $30?
$30, exactly. So make note of this. This is a complicated looking problem that is actually one of the easier problems. It's not a hard problem at all. So don't always assume that just because they look hard at the beginning that it's going to be hard. They're not. Just a little bit. There's actually two ways to do this. What way are you using?
can't you just, don't you have to do something with like 100 or something?
Well, if I've got something priced at $10 and I take 30% off, what's its new price going to be?
I have no idea.
Okay.
I don't know.
A $10 item with 30% off. Two ways to do it. I can take 30% times 10, that's $3. Since $3 is coming off, it's 10 minus 7, or, excuse me, 10 minus 3, or $7. So that's the most straightforward way to do it.
Okay.
However, that's two steps, because I had to multiply 30% times 10 to get 3, and then I had to take 10 minus 3 to get 7. It would have been much faster if I would have taken 70% of 10. In other words, 30% off means 70% of the original price. 70% of 10 is $7.
Oh.
So we could do this problem in two ways. We could take 20% of the price, subtract it from that, or we could do what?
You could do 80%.
Yeah, 80% of 660. Do that in your calculator.
Do I add them together or
Multiply.
528?
That's the answer.
Okay.
Okay. Okay, we have a squared equals 64 and b squared equals 81. Which of the following cannot be the value of a plus b? Well, first of all, tell me what a is.
8.
Plus or minus 8? Do you see why minus 8 is a solution?
Yeah.
Because minus 8 times minus 8 is plus 64.
Okay.
And what is b?
9. Plus or minus 9.
Plus or minus 9. So we've actually got 4 different combinations of a plus b. It could be 8 plus 9, 17. It could be minus 8 plus a minus 9, and so forth and so on. So could it be minus 17?
Yes.
Can it be minus 1?
Yes.
Can it be plus 1?
Yeah.
Can it be 17?
Yes.
Can it be 145?
No.
Immediately. So we did that the slowest possible way you could do it. I'm not sure that I would have been smart enough to start at the back and work my way forward, but this answer clearly is drastically different than the other 4. So I might have been inclined to start there. But the key to this problem is the fact that it's plus or minus.
Okay.
For some reason, about 90% of my students cannot remember that plus or minus. And I think it has to do with the fact that if I say this, what's that equal to?
3.
Only plus 3. Because,
why would it only plus 3?
well, because when I write it like that, I'm presuming a plus sign in front by convention. The same way that if I write the number 3, you assume it's plus 3. I don't have to write the plus in there. Okay? But this is completely different than solving this equation. X squared equals 9. And now you have to take the square root of both sides, so you get x equals plus or minus 3. So there's a huge difference between that and this. If I want minus 3, I've got to do this. Okay? But if I'm solving an equation that I'm taking the square root of both sides, always remember plus or minus should be the first words out of your mouth, as is evidenced by this problem. Although even if you didn't know that it was plus or minus, you'd be inclined to guess 145, just because there's no way you can get to 145 from any of these numbers, whether you knew plus or minus or not. All right, here we have two parallel lines with a transversal.
Are they transversal?
Well, hold on.
Is that what you said?
The key problem for both SAT and ACT is two parallel lines with a transversal.
Oh.
Understanding this concept. And I think in our previous couple sessions I have talked about it. When you have two parallel lines and a transversal, you create two angles, A and B. One of them is acute, one of them is obtuse. Every other angle here is either A or B. If it's obtuse, it's A. If it's acute, it's B. Okay? So that's the key thing to remember. The next key thing to remember is that A plus B is always equal to 180. So this is A, that's B. This is A, that's B, and this is B. If you can remember this about parallel lines and transversals, it'll take you a long way in the ACT test.
Okay.
Okay? So let's see what they mean here. B is the midpoint of AC. AC is parallel to DG, so we have our two parallel lines, and we have actually a couple of transversals here. So based on the drawing I just drew, can you see my pointer here, my hand?
Yeah.
What's that angle?
40.
If that angle's 40, what's that angle?
I don't know.
If I have a straight line and a line like that, these two angles, X and Y, always are supplementary. They always add to 180.
Oh.
And in fact, if I had a third line coming in, X, Y, and Z add to 180. In other words, a straight line is a 180-degree angle.
Okay.
So no matter how many lines you have adding up to that, they're all going to, or how many angles, they're all going to add to 180. Since this is just this one and this one has to be 140.
Okay.
Now, they gave us a lot of information here. that was unnecessary and irrelevant. It did not matter that B is the midpoint of AC. That's immaterial. I could have drawn my picture like this. Okay? And that still would have been 40, that still would have been 40, and that still would have been 140. It also did not matter that BE is congruent to BF, that BE is the same size as BF. BE is immaterial here. BE has nothing to do with anything. In other words, my entire answer is derived from that picture, and whether I draw another transversal or not matters not. Does not change the fact that this is 140 degrees. So, the lesson to be learned here is that not all of the information they give you is pertinent. Sometimes it's completely irrelevant. Their goal is to trick you. Okay? Their goal isn't necessarily to have you see the question as what it is. The question is strictly one of parallel lines and a transversal, like this. So all of this other stuff they threw in, this line BE here, is not important. So don't assume that just because information is in the question that it's important information. It isn't always.
Okay.
Hold on. Excuse me one moment. Let me get this positioned. All right. If x is minus 3, what do I get here?
Would you get 9?
Well, the best way to do it is don't skip any steps. In other words, write it out like this. Then the next step is 9 plus 18 minus 18 equals 9. So yes, 9 is the right answer. But don't try to do the whole thing in one step.
Okay.
You know what that means? You know what these vertical bars mean?
No, I don't know what it's called, but like I kind of know what they do.
It's called absolute value.
Yeah.
And what it means is whatever the numerical value is, you take the positive aspect of it only. In other words, if I came up with minus 17, the answer would be 17. If I came up with minus 2, the answer would be 2. If I came up with 5, the answer would be 5. So if A is 12, what does that equal to?
Negative 11.
Okay, that's what the inside is equal to. So I've got this, but what's that equal to?
Does it equal to 11?
11. Not negative 11, but positive 11. And notice they do put both answers on there. So if you didn't know what absolute value was, you might answer minus 11. But that would be wrong. AB equals C, C equals KB, and BC is not equal to 0, all right, let's first of all write AB equals C and C equals KB. So they want us to solve for K.
Like, how would you do this?
Well, there's a very important thing to notice here. This C is the same as this C. Otherwise, they wouldn't use the same letter.
Okay.
If AB is equal to C and C is equal to KB, then what can I say about AB and KB?
They're equal.
Yes. Very important concept. If you have a variable that's equal to something and the same variable is equal to something else, well then the something is equal to the something else. Okay?
Okay.
So what's K equal to?
I don't.
Divide both sides by what?
AB.
How about just B?
Oh, okay.
If I divide this side by B and this side by B, the B's cancel and I get K equals what?
A.
Yep. It's as simple as that.
Oh.
Some of these questions, I notice an awful lot of my students want to make them harder than they are. Some of them are very simple.
Just like that one.
Yeah, that last one is a good example. All right, how about this?
Would it be B?
How do I solve that?
Don't you just add the two?
Well, no.
No.
In other words, if it was x to the third times x to the 13th, then yes, because I'm doing multiplication, I'm going to do addition. In other words, you always do one level less than what's being done. In other words, if I'm doing division, I'm going to do subtraction. If I had x to the 13th divided by x to the 3rd, I'm going to subtract the exponents and get that. Okay? Well, this is not multiplication. This is not division. It's called exponentiation, which is one level higher than multiplication. Whenever you exponentiate something. So if it's one level higher than multiplication, and I'm doing exponentiation, then the answer is to multiply those.
Okay.
Okay? So let's just make sure you know this. So tell me what this is.
5.
Tell me what this is.
1.
And tell me what this is.
6.
Y to the 6th.
Oh, y to the 6th.
In each case, you left out the y. I think you assumed it, but no, you were correct. That's correct, and that is correct. Okay? Hold on again here. I need to move this up. The toughest thing about online is getting my things to fit the screen properly.
Yeah.
Okay, we have 2 over x is greater than or equal to 1 over 7. What is the largest possible value for x?
Would you not cross multiply?
Well, there is a problem with cross multiplying here. X is a variable, so I don't know whether it's positive or negative. So if I multiply both sides of this inequality by x, I'm not sure whether to turn the sign around or not, because when x is positive, it needs to face in the same direction it is now, but if x were negative, I would need to switch it around. So one of the things you cannot do with inequalities is multiply both sides by the variable. It's one of the few differences between solving inequalities and solving equations.
Okay.
So, assuming that I'm going to have a hard time solving this, what other way could I answer this question?
By the
Back solving.
back solving?
Always think back solving. If you cannot answer or figure out a question, always think back solving as your method of last resort. In other words, and it says what is the largest possible value of x. So we know where to start. Does 28, let's start with the largest number that we're looking at here, 28. Is 2 over 28 larger than or equal to 1/7? Use your calculator if it helps. You shouldn't need it on this problem, but if you can use it and it makes it faster, use it.
Isn't that false?
It is false. So what's the next value we should try?
15.
Okay.
Or should we do 14?
No. Well, let me think about that for a moment. I think we should do 15. Whenever it says largest or smallest, it's best to work with the smallest or largest and work your way the other direction.
Okay.
So is this true? Again, use your calculator if you need to.
No.
Okay. Next one. Now, look at this carefully. Do you need to use your calculator to determine whether that's true or not?
No, because it's the same.
Aha. 14 is the answer.
Okay.
Now, had I cross-multiplied here, I would have gotten 14 immediately. And if you'd answered that, you'd have been correct. But always remember that what I told you, that when you have an inequality equation, in other words, it's not an equation, it's an inequality, you cannot multiply both sides by a variable or divide both sides by a variable. Because if we're ever multiplying by a negative number, we need to reverse that direction. So that's not a good way to solve those, is by multiplying by variables. This was actually a pretty good example of back solving was the easiest way to solve it.
Yeah.
Okay. Wow. Another question where they give you completely irrelevant information.
How can you tell, like, what is irrelevant information?
Well, let's talk about a circle first of all. If I divide a circle up into 3 sectors, what do the sum of these 3 angles have to be?
360.
360. So if I divide a circle up into 12 sectors, what do the sum of the 12 sectors have to be?
360.
What do the sum of 5 of those sectors have to be? Each one of them are equal. If 12 sectors equals 360 degrees, 5 sectors equals what?
It wouldn't be 360, right?
That's correct. Here's all 12. Here's 1, 2, 3, 4, 5. So we're doing which part of the circle? What ratio of the circle are we taking?
6, 5.
5 twelfths.
5 twelfths.
Right?
Yeah.
In other words, we have 12 equal sectors. We know that all 12 sectors add to 360, so each sector is 30 degrees. Well, 5 of them is 150 degrees. Or we could just take 5 twelfths of 360.
So then what was the 46 pi?
That's the irrelevant information.
Okay.
That's what I said. This is another case where they give you completely unimportant, irrelevant information.
Okay.
It's a good thing to know because you don't want to always assume that all information needs to be taken into account. It doesn't. They will try to fool you. They're not nice people. How are we going to find the average of these?
Could you back solve this or no?
Not really. The reason I say that, you actually could, but in order to back solve it, you'd need to know how to figure out the average. Well, if we can figure out the average, let's just go ahead and do it, and we can save ourselves a lot of arithmetic. How do I figure out the average of these 5 numbers?
Would you do, I don't know.
Okay, there's average, which is mean.
Oh, so it has to be with mean, mode, and median?
Mean, mode, and median. What's the mean? Average is the same as mean.
So don't you add them all up?
And
Divide it by 5?
do it.
$434.
Sounds right. I didn't do it in my calculator, but I'm sure you did it correctly. 434. Okay. Now, notice that a lot of the answers are ridiculous. 462 couldn't possibly be correct, right? That's the biggest number. Now, I don't know that I could rule out any of the others automatically, and there's no reason to. What's important is you know that average is the same as mean. What's the median of these 5 numbers?
462.
The median. The median is the middle. You have to write them in order.
Oh.
What's the median?
433.
Uh-huh. And the mode is any of them. There's no number more common than the other.
Okay.
Can you see 15 okay?
Yeah. Wouldn't it be the first one?
Yes. I don't spend a whole lot of time on problems where I know you know how to do it and you do it okay. I'm not going to waste our time talking about it. Okay, number 16. Now, it's always worth looking at the answers before you attempt to do the problem.
Okay.
Because when we first look at this, it's not clear what they want. Do they want us to solve for x? In other words, we could solve for x, but that's, if we look at the answers, we clearly are not, that's not the problem, is to solve for x. The problem is merely to simplify this expression.
Okay.
So we could have spent a lot of time solving for x merely to discover that that's not what they want. So let's just simplify this. What's the next line in this equation? Or, excuse me, what's the next line in this expression?
7 minus 2x plus 10.
Simplify that.
Would it be negative 2x plus 10? Oh, 17, sorry.
Ah, it wasn't plus 10 though. 2 times minus 10 is what?
2 times.
Minus 2 times
minus
10.
20.
So it was really plus 20, which means it's plus 27. Okay?
Okay.
This is a good point to learn, because what happened was you made a math error. You knew how to do the problem, but you made a math error and the answer you came up with wasn't on there.
Yeah.
Well, that's an excellent point to note, that I probably made a math error. In other words, had minus 2x plus 17 been on there, we would have answered that and gotten it wrong. but the fact that that's not one of the answers gives you the information you need. I made a mistake on this. I need to go back and check my arithmetic. And that's all, because this is an easy problem. It would be a shame if you missed this. And you did miss it, but because the answer that you came up with wasn't on there, you get a second chance. And it's important to take those second chances. Go back and redo your arithmetic and make sure you do it properly.
Yeah, I tend to make that mistake often.
Well, everybody does. In other words, everybody makes a mistake with their arithmetic, but sometimes you get a second chance, like that. In other words, you made a mistake, but that wasn't an answer, so you get a second chance. It's like somebody standing over your shoulder saying, you made a mistake in your arithmetic, look at it again.
Okay.
Okay?
Okay. Is this like the other problem?
This problem you can do algebraically, or you can back solve it. Either one. Depends on how comfortable you are translating this sentence into an algebraic equation. Try to do that for me. What does it mean that 60% of x equals 90? Write that, give me that as an equation.
So
60% translates to what if I'm going to write it in an equation?
60x.
Yeah, 0.6. The of always means times. That's multiplication. So 0.6x equals
90.
90. Now solve that on your calculator.
$150.
Right. So easy enough. Well, let's look at back solving this. 60% of some number equals 90. Does that number need to be greater than 90 or less than 90?
I would think less, but...
No, greater than. Because 60% is something less than 1. So if I say 60% of 90, well, that's only going to be 54. So the number has to be bigger than 90 for 60% of it to be equal to 90. So if I'm going to back solve this, I'm only going to check these two numbers right here. I don't even need to worry about those three numbers. I know none of those can be correct. 60% of 54 is going to be a number less than 54.
Okay.
60% of that number is less than that number, and so forth. Notice that 99% of a number is always less than the number. Right?
Yeah.
Okay. So if I'm going to back solve it, I only have to worry about those two. Well, you could start this problem right out by saying, well, what's 60% of 150? You'd have got 90, problem over, done.
Okay.
If you take 60% of 1,500, you're going to get 900, not 90.
Okay.
Okay? But it is important to be able to answer that question. If 60% of a number equals this number, then this number has to be bigger than this number. What if I said 150% of x equals 100? Does x have to be bigger or less than 100?
It has to be less than...
Yeah, Exactly. We started at 2:30? Yeah.
Yeah.
Okay, we got a few more here. All right, we're actually making pretty good pace. Do you remember what I said about the first step in a word problem?
Is to take out, like, is to look at the question.
Define your variables and spell them out. So, give me a variable and let's define it. What are they asking for?
Cost of one drink.
So let's let D equal the cost of a drink. What's the other variable?
Price.
Popcorn.
Oh, popcorn.
Popcorn equals the cost of popcorn. Okay? Now from the first sentence, what can I say? With regard to my variables.
D plus P equals 510.
From the second sentence, what can I say?
2D.
2P, right? So it's D plus 2P equals 835. Now I have two equations and two unknowns.
Okay. And then
How do I solve those?
can't you do like elimination?
Yes, let's do it. How am I going to solve this by elimination?
By doing a -2 times the top one by -2.
By -1. Oh, okay. No, -2 actually works. Yeah, that's fine. So -2 there. Changes that to -2. Changes that to -1020. Now what?
Well, -2p cancels out.
So the P gets eliminated, which is good, because it means we're going to solve for D, and that's what they want, the cost of one drink. So first of all, why did I multiply the top by -2?
To eliminate 2p.
To eliminate the P's when I added these two equations together. So the next step is to add the two equations together. What do you get now when you add these two equations?
2d.
What do you get? I got a -2D there and I got a D there. When I add those together, what do I get?
-1.
-D. When I add the P's together, I get 0. And when I add the numbers together, what do I get?
-185.
So if -D is equal to -185, what's D equal to?
Doesn't equal to +185?
Yes, it does. And that's the answer. Okay?
Okay.
Couple of ways let's just talk about to solve this problem. When I got it to here, you can both add or subtract equations. You don't always have to add them. Well, if I write this one below, instead of above, and now I look at these two equations, and if I want to eliminate a variable, what can I do? I can just subtract them. I can subtract them right off, right? The d's cancel. 2p minus p is p. 835 minus 510 is 325. So by subtracting the two equations, I solve for p immediately. Of course, the problem wants to know what d is. So how do I solve for d now?
Plug it back in.
Plug it in right there, 325. D equals 510 minus 325, which is 185. Okay? So just know that you can always subtract equations. If you happen to have two equations that lend themselves to subtracting like that did, notice that when I subtracted them, I had no negative numbers, I had no negative variables. Whereas the first way we did it, you kind of had to get negative numbers on top and then add them. Now, granted, we did solve for D immediately instead of P first, but I'm not sure that it was necessarily the easiest way to do it. But you got it. That's what's important. All right, let's stop there.
Okay.
And in order for me to send you a copy of this recording, what's the best way for me to do it? Your email address?
Probably.
Yeah, your mom might want to look at this also, so I'll certainly let her know that I'm sending you a recording of these. Maybe she wants to see, how it plays out online.
Okay.
So go ahead.
You just want to send it to my mom's email altogether.
That's fine. Go ahead and give that to me, and I'll make sure I send it. It takes about 3 hours to have this processed, but I'll send it to your mom's email as soon as I get it done.
All right. K. GIE. LAS. at Comcast.net.
She will get a link by sometime later this evening, I suspect, that shows her how to view this.
Okay.
Her and you, if you want to go over this. I don't know if these are going to be that valuable
they'll be
for you or not.
helpful.
They might be helpful, but they might not also. This is more practice. In other words, it's if we were studying calculus and there were principles that you were learning for the first time, then it would be extremely helpful for you to go back over and review this. But we're not really doing that. We're practicing what you're already supposed to know. It's still, if some of the stuff we've covered is new stuff for you, then it might be of value to you to go back over it. But probably not as much as if we were learning a new material.
Okay.
But I'll definitely send the recording. And then as far as next week, you want to plan on in-person next Monday?
I like the videos.
I thought you would. So let's do online next Tuesday, or next Monday at 2:30.
Okay.
I'll just leave it on my calendar for 2:30s on Mondays, online, unless I'm notified differently.
Okay, sounds good.
Okay? All right, Lauren. Have a good week, and I'll talk to you next week.
All right, sounds good.
Bye-bye.